Hey, hello there, and welcome back for more Advent of Code. So, today is day 6, but before jumping into today's puzzle, I still have to clean some things up from yesterday's puzzle, or the thing that I did yesterday night, where I optimized day 5 solution to run in just a couple of milliseconds instead of taking a couple of minutes. So the code for that thing is pretty horrible, and I wanted to give it a try at maybe cleaning it up a little bit, and leaving it in a more or less okay shape before jumping to something else, because I feel like I still have some of this context in my head, and maybe it's better to just do it now instead of doing puzzle 6 and then coming back to this. So I have the code in the same state as yesterday. I just staged the changes, but if we unstage them, basically we can see that we added all the code in this min location part 2 function, which is kind of a mess, and then part 1 we didn't touch anything. So I think the first thing that I want to do is just simply clean these things up. That print statement, these are comments. These other if statements probably also need some similar comments, but just print this up, clean this up, sorry, and maybe run check all to see that this is still in good shape. And yeah, you can see that running, if we run for the sample, or no, sorry, not for the sample, I meant to run for the actual input. Well, it takes no time, it just is instantaneous, so that's awesome. And yeah, let's first just commit this as the first improved solution. So how could we call this? Optimize day 5 solution by using interval logic instead of brute force. Great, that's a very good message. It's exactly what we did yesterday night. So what can we do to make this less unwieldy? Well, I have a couple of ideas. The first one and most obvious thing that comes to mind, I should also have cleaned this debug thing. Let's do that. Those are some useful Git aliases that I have. First thing that comes to mind is our solution for part 2 is very general now. So we can use the same solution for part, the solution for part 2, we can use it for part 1 also. Just in part 1, these seed numbers are single seeds, but we could transform that into ranges of starting at this seed and having length 1, and just use part 2 solution to solve part 1, and that would get rid of all the specific code for part 1. So that is, let's actually maybe take note of the things that I may want to do. Let's say to do reuse part 2 logic on part 1. Yeah. Well, a very stupid and simple thing that I want to do is just not use VecDeque here, don't use VecDeque. It's not necessary, we can just use normal vectors. And then there is 2 things that I want to try that are a bit more involved, probably. First, I want to try out what would happen if we used ranges defined by start and end positions, or start and end numbers, instead of start and length, because I feel like a lot of the math computations that we are doing here are more complex than they should. Like, they are difficult to reason about. Yesterday when I was doing this, although it was pretty late and I probably wasn't as, you know, I was a bit sleepy. So yeah, I wasn't as focused, as sharp as I could be. Still, I feel like probably if we had like start and end intervals, this would, I think, be simpler to understand. So that is something. Try using start, end, and I don't know, like, if we try this, I don't know if it would be better to use an inclusive interval that includes the end, or start and non-inclusive, that, like, this is like sort of the math notation for this, that doesn't include the end. I just simply don't know what will be more convenient. Like, this sounds, I think in theory, more convenient for this problem, but oftentimes using open-ended ranges yields like simpler solutions. So I don't know. And the other thing, like, I guess the most important thing that I would like to try out to refactor is, well, cleaning up a little bit of this logic here. We have 1, 2, 3, 4, 5 and a 6th unreachable, so this doesn't count, this doesn't happen, but 5 different cases of how these ranges can overlap and do stuff, and I feel like that is too much. I feel we can probably, oh, my cat is attacking. We can probably simplify that by a whole lot. Maybe I should increase the font size. No decrease. Oh man, this code is pretty gnarly when you look at it close, and you realize how much it is. But yeah, I feel like we can probably greatly simplify that if we thought about ranges. Sorry, I will decrease the font because that's too much for me. I hope that it's readable in the video. Yeah, because here we are basically considering every case very differently. Like, the first case is where the ranges, we have 2 ranges basically here. These start and length, which is like the ranges of seeds or whatever material that we are working with. So 7914 and 5513, for instance, are the 2 ranges at the beginning. And then these mapping ranges, or range map, I call them. I don't know if that's a good name, but anyway, that they have a source start and a length, and that basically behaves also like a range. And then we are doing sort of interval math. I don't know if I should call these things intervals or ranges, because interval is the most mathy name, and range is I don't know, a more colloquial name, I guess. But maybe I should use interval, because Rust also has a concept of ranges. Like when you do like I don't know, 0 to 5, this is a range in Rust. But using these ranges from Rust would not be good for what we are doing here, because these ranges are iterators, that they are not meant to be used as like mathematical intervals. Man, I went on a tangent there. Let's come back. So what I was trying to get at is that here we are being very specific about the different cases. So the first case is, well, the ranges don't overlap. The second case is like our outer range is entirely within the mapping range. Then this other case is the other way around, where the mapping range is entirely within our outer range, the range with which that we want to map. And this is the most complicated case of the 5, because we need to map a a part of the range itself, but then we have two ends, and we modify the range that we are iterating. Yeah, this is a mess, and then we push the other bits to the back of this queue of ranges to be processed and be mapped later. And then these other two cases is where they overlap at the beginning or at the end, basically. So I feel like this is a bunch of stuff, a bunch of cases, and we could probably generalize this much better if we thought about it like in a more abstract and mathematical way, like thinking about like interval intersection and maybe interval difference or something like this. So if we would do the interval intersection between the two intervals, and that would be a new interval, then that is the interval that we need to map. And I think we should be able to express that in a general way. And then we can probably do the difference between that intersection and what we are trying to map, and I don't know, gets the other pieces. But yeah, in short, I think that we can greatly simplify this code by thinking of interval intersection. So simplify code by using interval, by modeling, say, interval intersection and difference. That is, I think, the most important thing that I want to do, or potentially the most valuable thing, I think, to get this in a more readable state. And the last thing that I was thinking, maybe, is to simplify a little bit basically the main logic of these loops. Basically, here we have 3 nested loops. Beautiful. And although that will still be the case, I think, I don't really like how we are mapping these ranges using this while and consuming things. And we are also having like a mutable copy of the range here that we are mutating. I should stop saying range and say interval, or like choose one of those 2 words. But yeah, basically we're grabbing, let's keep calling them ranges. We're grabbing each range that we want to map. We pop it from this queue, and we try to go through all the mapping range maps that can map this range. And when it intersects with some, we map the intersection, and we put it in this map ranges the queue, or queue, sorry. And then what's sorry, I got lost. Yeah, we map the intersection, we put it here, but then we modify the interval that we are working with to reduce it, take out the intersection and keep going and keep trying the other range maps to map it with, which I think is good logic, but it's expressed in kind of a convoluted way. So I do wonder if there is a better way, and there probably is, like using iterator logic of, I don't know, mapping things and things like that, instead of thinking in like vectors and pushing and popping things into vectors. I don't know if I will be able to do this in this sitting, because at 14 and something I have to get going, but let's also take note of that. So simplify main loop logic. Don't use so much mutation and so much mutable state, let's say. Like I would like to have like less things being mutated and have a more like easy to follow logic. So okay, those are kind of the things that I would like to do. Let's start with the simplest one, which would be to get rid of VecDeque. And there is also, there is one little thing, because I'm going to be doing these refactors and I want to, well, I could run the check all command every time I do something and see that it still gives the same result. But there is something else that I want to check, which is this necessary? I want to check a couple of invariants that, you know, I'm not screwing things up. One of them is that in the ranges, the total length, like if you add the length of all the ranges, that needs to stay constant. So if we print here, for instance, let's show this, total length is ranges iter map. Sorry, what do I want to map? We want to map to the second, I guess, second thing on the range is the length, and then we want to sum into a U64, okay. And if we run this, well, we get some failures here because we are comparing outputs, but if we do maybe an E print line, we get away with, yeah, look at that. So in the sample, the ranges are 27 length in total, and in the real input is this huge number, and you can see that they stay the same. And also I want to say, okay, total length is this, and number of ranges, let's say, is what? Ranges length. And if we run this, you can see how the number of ranges changes with each iteration. The main loop here that we, the outer one where we are printing this in, is the loop of each map that we have, and each map is one of these. So we go through every one of these in order, and the number of total ranges increases because sometimes ranges split, and you can see that in the sample, but in the actual input they split, well, quite much more, and by the end of it you have 65 ranges. So that's good to know. And I want to print these things as sort of a sanity check or smoke check, you know, just to have information of whether I'm screwing things up or not, because I don't know, I fear the case where I may refactor something and things still work, but I screw some of these things up. So I probably want, yeah, these numbers to stay constant, and by the end of the actual input, sorry, this will be actual input, have 65 ranges. So I will keep an eye on that. Now, that being said, let's not use VecDeque anymore. I don't know what I did there. I tried to change both. Now we don't have pushback, of course, but we can just simply use vector push. And from a vector you can pop from the back, not from the front. So this changes the order of iterations. So this basically is the case that I want to check. And yeah, it seems like the number of things, of ranges, is still the same as it was before, and the answers are still the same. So that's a very good sign. Like, we changed the order of iteration. Basically, before we were pushing things on the back of this, but then popping from, where is the pop? Where's the pop? Here. We were popping from the front, so this was a first in, first out queue, and now we convert that into a last in, first out, or a stack basically, but the answer is still the same. So that's great. That is, I think this is the only thing that could change the order of iterations. So maybe I can, yeah, I can just get rid of this. Let's let's get rid of it. So that's already a good change that I can commit. Say use normal vec instead of VecDeque. That is actually the name of this is not VecDeque. I don't know what this deque. Maybe I'm pronouncing this completely wrong, and I actually don't know what deque or deque means. But I know it's like a circular buffer for vectors where the beginning and the end can shift. Anyway, yeah, that's great. Commit. Bye. So this is done. Maybe you can try also reusing parts, part 1 logic in part 2, maybe. Yeah, let's give that a shot and see what happens, because we have some things remaining from part 1. Yeah, and the parsing logic and all of that. So for part 1, what we could do, I'm thinking of if I should extract this logic of part 2, all of this for loop, into something, or just call part 2 from part 1. I will do the latter. So here, what I want to do is convert these seeds into ranges. So let's say let ranges, it's gonna be seeds, iterate over them, and map this, well, seed number, it's just a number, and the range, yeah, right, it's just a tuple, or you can use an array. So it's just gonna be a range of this number and length 1. And I don't mean to use map, I mean to use flat map, because this thing again receives this thing as flattened up. Maybe I should extract this to have something that receives the ranges itself and call that from part 2 and part 1, but yeah, let's do this for now. Yeah, this is correct, right? I think so. We can collect. And we then call mean allocation part 2 with the ranges, or yeah, the flattened ranges basically. And you don't like this because consider borrowing here. What? Collect cannot be. Oh, it needs. Yeah, let's say collect this into a vector. Is this correct type? Yes, it is. And then we need to pass it like this. Yeah, that's fine. And does this work well? We have a lot of warnings of unused things, and that's good. That's what we want to get rid of. But yeah, the sample passed and the actual answer passed. So this is another confirmation that our logic is correct, because it's also working for part 1. So we can get rid of this function, simple function that we used for part 1. That's great. That is less code overall. Yeah, this is maybe a bit tricky, doing this like this. I'm wondering, this takes this thing and yeah, for now let's leave it like this. We will see if we can express this a bit better. Ranges is flat and flattened ranges, maybe. That's what we have. Yeah, it's kind of a hack to use it like this, but it's fine. It works all right. What else can we do? Well, we have already done this. Let's actually commit this if we don't have any more warnings, and we don't, so let's also commit this. Reuse part2 logic, or implement part day5 part1 in terms of part2. I think the previous commit messages that I had used, wow, yeah, they are fine. Okay, what else? What should I go for next? These are more involved refactors. I will have to think a bit more. I really want to try these. I don't know if, because I think this has the greatest potential for simplifying things. And I don't know if changing these ranges to start and intervals, like if I want to do that with a complex code, maybe it would be better to do it after we refactor this into like using intersection and things like that. So ranges don't overlap. How are we going to do this? I think I have to bite the bullet and have some struct for the ranges themselves. Do I want to call them range and shadow Rust built-in ranges? Maybe that's a bit confusing. Maybe I should call this interval. And range map is confusing. Let's keep calling this thing range for now. And we're gonna have a start. That's gonna be a U64, and the length. That's also U64. Okay, that's what we have for now. And here, we are not going to have a vector of these two things. We want to have a vector of ranges. Yeah. Let's say then, vector of range. So it's not just tuples that we're gonna have here. Now what I'm thinking, I'm thinking that this is really nice expression. Clone tuples collect. It's cute. Here we need to map each tuple though. So we're gonna map it into a range unless we know how to make ranges from tuples, but let's have start and length and create a range with start and length. And now it's not as beautiful as a one-liner as it was before, but it's okay. We have it. Okay, yeah. And now when we are iterating over this, well, we can have a range, right? We are not using a variable called like this, and here we extract these things from the range, and this is actually, can we do something like this structure like this, range? We are not changing the logic, we are just, yeah, kind of ugly, but let's keep going. Let's keep going. Here, when we push another range to be processed, we have to use, well, a range, not a tuple anymore. So this is the start, this is the length. Okay. And mapped ranges, now this also needs to be a vector of ranges, of course. So when we, okay, I see that we are doing a lot of this range constructing, so I probably want to have, you know what, well, we can have the input of range over here, I guess, or down here. So input range is, we need to have a new function that, you know what, let Rust Analyzer generate that for us. So where is a case of that? Here we want to say, or I guess here it's going to be more obvious, new, and pass two parameters as we, like, this is going to be more similar to the tuple code. Now new, I guess, can be generated. Yeah, look at that. It got generated correctly. So this is the start, this is the length, and here we just do range. Perfect. And perfect. Very stupid one-liner function, but you know, it's, I think, will make sense to use. So when we push things to these mapped ranges, we need to, well, do range new, and that should be simpler. Now we follow the errors. Range new, range new, range new, range new. And here what we are mapping is, well, a range, and range dot start. That got better. Okay, I extracted these things into a struct to, well, have a name for it instead of going with tuples for everything, and now have a place to put like intersection and difference and things like that. So of course I could have these functions be like free floating functions, top level functions, but that's not the issue. If I had a top level function, I guess, yeah, I could have had that and take two tuples and return a tuple and have the ranges just be tuples. But I think I want to do it this way. There is also, you know, the possibility of range itself defining it as a tuple struct, which is, you know, something that Rust supports, and maybe it will make more sense, but let's not change everything all the time. So let's have an intersection function. So intersection of self and another range is gonna give me back a range, and since I am taking the other like this, let's make this things be just copyable. Derive copy. Oh, and I think copy needs clone. Sure. I don't know if I should take self not as reference, maybe. Take it by value and it will be copied. But how does the intersection work? We have the simple code here, which is like the case where they don't overlap. And I think checking for overlap is basically, well, turning this condition around. And let's think about it. If we have range, let's say range A and range B, and A is, let's simply draw it, or let's draw it with something like this. Oh, look at those those ligatures. And let's say the range B is something like, woohoo! Man, the font ligatures are amazingly fun. Something like this. The not overlap case is easy to check. We just check if the range A ends before range B, or if range B ends before range A. I think that's what we are checking here. This is the end, and it is before, yeah, the other guy. That's awesome. So, well, I call this A and B, but here I'm calling self and other. Anyway, and this is an OR case, right? Yes. So I guess making that, inverting that condition would be if this ends after B starts, and so ends after B starts, yes, and B ends, I don't so you see, it's so difficult to think about interval logic. So this is the condition that we have. Let's convert this to the names that we have. So no overlap is equal to A and also, yeah, to me it's easier to think about start and end instead of length, start and length, but okay. A end before B start, or this start is A start is greater than B end, but it's the same to turn it around like this. A start. So yeah, okay, this makes sense to me. This is the no overlap function. So the overlap case is just turning it around, negating this basically, and applying De Morgan. That would mean A end is greater than B start, and B end is greater than A start. Does this make sense? Is this what we see here? So A ends after B starts, yes, and B ends, yes, after A starts. And this, I think, you know, if you have it the other way around, so in this case, A ends after B starts, but also B ends, so this assures that there is an overlap. Yeah, it was pretty simple to think about it. So that is what we want to express. And you can see that this thing wants to, like, sort of wants to be expressed in terms of start and end. Really. Okay. So can we actually like just say that? Can we say this is A and B? Now let's call it other. So A is self. So this is basically if, and then we have to like compute actually the, so this is the condition itself. And here I could return, I guess, an optional range. But I was thinking like we can represent empty ranges by saying that the length is 0. So it doesn't, you know, it's not necessary to return an optional. We can just return an empty range to represent no intersection, because like in the using code we still have to check, hey, is there an intersection? So we will just ask, hey, is it the empty range? So I think this is fine. So how do we actually get the intersection? So if we get the minimum start from, the maximum start and the minimum end, that is intersection basically, right? Maximum start, a minimum end. Yes. That is intersection. So actually, this can be expressed really nicely, I think. And you know what I want? I want a function end. Self. And this, do I want inclusive end or not? This is just self start plus self length -1. Yes, this is U64. Okay. So we can do this if condition, or we can just say let intersection start be self start max other start, so the maximum between the two, and then intersection, well, end is self end and the minimum of the two ends. Okay. And then, so the case where they don't intersect, so here, for example, if we get the maximum start is going to be this, but the minimum end is going to be this, so the end will be before the start, and that means no intersection. So if intersection end is, and this end is inclusive, so intersection end, so there is an intersection, we will return range new with intersection start and the length is gonna be intersection end minus intersection start plus 1. Yeah, beautiful. And else, what are we going to say? Actually, let's extract this into oh no, we cannot do, since this is, well, we can actually extract it into a variable. So this is length, and this is the intersection length. But we cannot do this because in the case where end is greater than start, where start is greater than end, and that means it's there is no intersection, then this will underflow because these are unsigned integers, and that's a good thing that it underflows. Like we shouldn't be subtracting this. So we can actually ask this thing here, and in this case this is the length, else the length is 0, so empty range, and then we always return the range starting at this start, and the length will tell us if it is empty. Okay, so I think that is intersection, and that's great. Yeah. I'm even thinking ahead of changing these ranges to be start end ranges instead of start length. But okay, we now have the idea of an intersection. Now what? Ranges don't overlap or blah blah blah. We can start using this intersection. And we are gonna need another operation also, but let's think about that later. Say, let intersection be, we do have our range. Oh, but we don't have, actually this range map doesn't have a range, so we can construct one of those. Intersection with range map, let's say this is the source and destination, right? So source range, we could say, give me that. Yeah, let's have that, and I'll probably want to change this. You know what? Let's bite the bullet and do it now. Like, what I want to do is, here we have source start, destination start, and blah blah blah. Let's comment this. Let's actually first rename this, because I feel like these names are a bit long, especially destination. We can say SRC and DST, the classic names for source and destination, and that changed a lot of lines, and I hope that's, well, many lines should have gotten shorter because of that, because we were using those things all over the place. So yeah, source, destination, blah blah blah. Great. And this should still work. Yeah, with some warnings, but it works. Now, why did I make that change? I also want to make another change. We have the source start and destination start. Let's actually have we could have source and destination ranges, but I think like if we had that, let's write it and get rid of the length. But if we did that, what is the problem with this? Well, we have to keep the invariant that the length of these two ranges is the same, and it's information that I don't even want to like write down that invariant. So I will say that the source is a range because that's the thing that we want to do range math with. But then the destination is just a number. It's just the destination start. We don't need the destination end length for anything. So let's just keep it like this. And now we have to fix a bunch of errors, but I think they will be overall pretty simple. So let's call this thing first the dst start. So this gets replaced by that, and then source start. This is src start. Great. But now we just need the source range, and yeah, let's say src is range new with source start and length. Bye. Awesome. And maybe even have you into a variable called source and have this very neatly packed. Great. And now we have a bunch of things to fix here, but all of this source start, which are a lot of them, are gonna be replaced with just simply src.start. So blah 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 blah. Oops, not that one. Oh, I don't know the shortcut for going back in this selection. So all of this up to here is just src.start. Okay, and the length that is broken, I guess this thing could have a method length that delegates to the other thing, but let's just use src length, which is where the thing lives, because now we can see that we are doing src start plus length all over the place also, and it's like they are two things that go together, and that tells us, I think, that we should be thinking about start-end ranges. But if we run this now, still works nice. So the refactors are being pretty conservative. And yeah, now let's try to use the intersection for once. Intersection. So what do we want to say? Well, first, let's keep this logic of, well, if there is no intersection, if the intersection is empty, we just continue. So let's say if intersection is empty, continue. Okay, and of course this is, oh, and this doesn't need to be source range, it's just the source. Awesome. And this is empty. Should be pretty simple. It's just asking if the length is 0. Okay. So now we know that there is an intersection and we need to map that intersection. So let's first make sure that we did the intersection correctly, and the isEmpty is checking the same thing as before. Oh, no, we got a failure. Look at that. Already a failure, but but this passed. That's annoying. So it seems like this intersection is not exactly the same as what we were doing before. That's great. If we do it like this, still passes. Great, great, great. So this is, they don't overlap. Don't overlap, but it's not the same as this. What a fantastic thing to find. But I think we can easily debug this. So if we say if intersection, what we want to say, like say let A be intersection is empty, and let B be this condition, and we want to see when these two things don't match, right? So if A is different than B, that is our problem, and let's print something and say conditions, well, oh no. And what do we want to know about? We want to know about basically what range we are in, and say range, and what is this thing, the thing that we did the intersection with. Weird. I mean, I thought it was pretty obvious what we did, but apparently it wasn't. So here, let's also have debug information. Oh no, we have a couple of cases, and these giant numbers are not very. Oh, you know what? I should also print A and B. Oh no, let's say A and B, and I want to see the intersection also. So intersection, which we know, well, we don't know if it's empty now. Intersection, range, and range map. Lots of information. Put this over my head and see. Oh no, false is different than true. So the A is false, so this thing is not empty, the intersection. We can see the intersection here has some length. It's actually pretty long. So it's not empty, but B is saying, hey, there is no overlap. So who's right? So we were doing intersection between range and these, so this thing starts at 364 million. These numbers are horrible. And the other one starts at 500 million, which is a lots longer, but they should overlap, right? Because the length is 400 million, and if I'm not mistaken, 300 million plus 400 million, well, we'll touch this for sure. And the length of this is a bit short, 18 million. So maybe this range ends you know, this man, these things are so difficult to watch. we want to say, okay, the intersection, let's say start and end, and the range, we're gonna also do start and end. It's gonna take a bit more, but we're gonna have intersection start, intersection end, and then we are gonna have these other guys. So range start and end, and range map source start and end. Beautiful, beautiful. Okay, less numbers. Okay, so this is also assuming that the end method is correct, but that was pretty simple, I think. So this thing starts, no, the intersection starts, it's not too big, the intersection. And it ends, well, let's see this. So this is this and 700 million, and this surely intersects with this. Yes, but this ends, so this range is completely contained within this. So the intersection should be this. Yeah, wait. They should completely, like, this second range is completely within this one. So the intersection, like this number, actually all of this, if we search for it, is the same. Like the intersection is this range. So it is correct that the intersection should not be empty. And we shouldn't continue. So if it is empty, which it's not, then we're continuing. But this other condition is saying true, and we continue on, but that's not the case. So what is this condition saying? The start, this, no, sorry, this is the end is less than range map start, but this is incorrect, right? Start plus length minus 1 is gonna be, it's the end of this of our range. This thing, this is the end of our range, and it's not before. So this is not true, but then this will be true, right? So the start of the range is greater than, yeah, the end of the other. Huh. So the end is less than the start of the other. Yeah, in that case they don't overlap. But the start is greater than the end of this. So yeah, this ending number is 586, and this no, the start is not greater than this. Start is 568. So there is, how is this true? How is B true? Damn it. I don't understand. So B equals or and both of those are these. This is one of the most horrible print debugging statements that I have done in a long while, but once you start with a train of thought, you have to carry on. Commas, of course. B is true or false. The first part is true. What? The end of this range is less than. What is happening? The end of this range is 700 million. But this is like, what? These are all 64-bit numbers, right? Yeah. How is this less than this? I'm tripping, like, what? Start. Am I seeing things correctly? This it seems like the other cases are also similar to this. So what's going on? I want to see then, like, okay, this thing is true. We know that, well, we know that if you're watching this video, you're probably wondering, how am I such an idiot that I'm not seeing things correctly? That's the end. Oh, wait. This range, we copied it. Ah, shit. Yeah. I think I know what I'm. Yeah. We extracted this range from here. Great. This is a fuck up on my part. But then we did this where we copied it into these two variables. But then we are using again this range for the intersection here. But this is the thing that we didn't mutate, and we should keep track of that. That's the problem. That is the problem. I'm sure. So let's actually extract this into a mutable range. Do not deconstruct that range, and just fix all of that. But yeah, I'm pretty sure that we will just keep printing oh no here if something goes wrong. Let's not print all the debugging information that we have. So let's say simply oh no, and not print that, and not print any of that. Simply oh no. And yeah, all of this start, length, blah 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 are all gonna be part of the range. Kind of maybe an annoying refactor to do, but I think it's worth it. And then we are going to mutate that thing. Okay, just keep going with it. Here we modify the range. Yes, that's the thing that we were missing before. Can we actually, like, no. Let's keep going with this. Sure, there was a better way of doing this. Yes, and I can think now I could have renamed these variables and do this only once, but I'm already started doing this. Okay, almost there. And if the range length is different than 0, we also have a method for doing that. But okay. Do we have oh no's now? No, we don't. Okay, that was the stupid problem. What a stupid problem. Great. We don't need this debugging. If the intersection is empty, we continue. We don't need to save this. And let's run now. Still okay, great. Now, we do have the intersection. We do have the intersection, that's great. With that, I think we can already get rid of most, if not all, of these mapped ranges.push, because we are just going to map the intersection. So we're gonna say we do have an intersection, then ranges do overlap. We're gonna push a new range. I guess we could have a method to map a range, I guess, but or to move a range by some time, but by some amount, but it's fine. We need to we have the intersection, we have to map the intersection with this range map, and that is exactly what we are doing in cases like this mapped, like this mapped start. We just say the range start minus the src start. Yeah, this is sort of what we want. So we are gonna put the intersection into here. So this is the intersection start and the mapping of things. I think that should be fine. And the length is gonna be the intersection length. Maps do overlap, or ranges overlap. Yes. Map the intersection. Okay, and with that, I think we can get rid of all these mapped ranges dot push. So goodbye you. No, goodbye you. Goodbye all of you. Goodbye all of you. And now all the if and if else cases are just modifying the range or putting things to work later. So now let's check again. Is this correct? Yes, it is correct. Okay, our intersection code was always correct. We just screwed up, and you realize like that screw up, and that took me a long time to realize. And by the way, I should get going. I have some time still, but yeah, that screw up was entirely because I was using too much mutable state. That is the source problem there. The root cause of the stupid bug is just having more mutable state, and things changing when you don't expect them to. And yeah, it's kind of the root of all evil, having so much mutable state. Rust did a great job at designing variables to be immutable, but by default, and having to explicitly opt into mutation by saying, "Hey, this is a mut," and it actually checks a bunch of things about mutability. So that's great. We should do less mutability, less mutable state, if possible, always. Okay. So that's a nice simplification already, and I think even this gunk that we have can be simplified further. So this case is when our range is entirely within, range is entirely within range map dot source. And in that case, we have mapped everything and we keep going. So what I want to do is, instead of expressing this like this, I want to do something like, okay, we have mapped the intersection now. ranges overlap, map the intersection. Now I want to do something like let difference between what? Range difference and intersection. We subtract the intersection from the range, and this is the difference. This will be my new range, basically. And that will be it, I think. So how are we going to express that? In fact, there is even before, like, let's leave this as a to-do. I want to try one last thing and then get going. I have a question, which is, do I need to keep mutating this range? So this works now, great. We can run this thing with the actual input. I have an idea of how much time it takes. Well, it says 103 milliseconds, but I think this is mostly due to due to cargo run startup. If we run just the binary, the runtime is very short. That's great. So yeah, what I'm wondering is, can I get away with not mutating this range? And of course, with this, we'll have a bunch of errors regarding to this, because we keep going through all of the range maps because we are sort of consuming the range. But okay, we know that there is an overlap here. Great. So we have overlapped with this range map. That's cool. Now, what I want to try out is, okay, here range is entirely within the range map, so we have, this means that we have mapped it all and we don't need to do anything else, I think. In this case, just break. Yeah, don't do anything else. Don't modify it, don't do anything else. In this case, we are pushing this is the end bit, this is the most complex case, but we can also, instead of modifying this, we can push another one, another range to process in the back of this, where the length is going to be this, and the start is just going to be the same start as before, so range start. Yeah. This is sort of a similar case, if not. Yeah, this is basically the same case. We push it to be processed. And here we're modifying both the length and the start. The length is this thing, and the start is this thing. So it's actually the same as this. We are pushing these things back to be processed later, but we are not modifying anything. This should still be unreachable, yes. If, okay. So we know that we have overlapped and we have pushed something to be processed. Like we push the remaining bits to be processed. And I think we can, in this case, break out of the loop. So we get the next range to process. And this is now not necessary because we are not No, this is, sorry, that is basically, no, that I think that is necessary. When we end this loop without modifying anything, that was kind of important actually. Here we're trying to map the range with this range map. If we are successful, like if all the intersections are empty, it's like this code will never be executed. And that can happen. And that means that no range map intersects with our range, and what? And so we have to keep the same range in the mapped ranges. Yes, that is correct. So here, let's do it with a boolean. Let's mute bool did intersect. We're gonna say false by default, and then, well, here we continue. At the end of here, this I don't want to early break. Then here we're gonna say, okay, it did intersect. And now we can ask here if it didn't intersect with anything, then we just push this range as the mapped range. What about this? Does this work? Did we create a enter unreachable code? Okay, no, it didn't work. Great. Oh, this is not an else. I was stupid. Was that the problem? No, it still entered unreachable code. That's weird. I thought I was checking all of the possibilities. Like, what did change? We are not modifying the range itself because it's no longer mutable. We are, oops, still have the same thumbnail as before. So are we entering, yeah, this unreachable code? What's happening here? We're pushing ranges to be processed. I think I probably screwed something up in, well, definitely have screwed something up in this logic. Did intersect true. So yeah, we care about this. Like, we are always discarding the range itself. Yeah. Yeah, okay. Well, I cannot think about this now. I have to get going, yes. So I will undo until we get back to where we had immutable range. There. Okay, this. Oh wait, was I running this thing and not rebuilding? That was so stupid. Let's redo everything. And I should actually do cargo run. It did execute, and it's I'm an idiot. Let's check all. Yes, it was the problem was the if without the else if, which I fixed, but I was not rebuilding the thing before running again. Okay, so this thing still runs. If we time this now, is still within 2 milliseconds to run. That's great. And this again simplifies the code greatly, I think, because this is just caring about well, it's not mutating the range when we iterate them. So it's much simpler. We just keep a Boolean variable to know if it's intersected with something, but we are not changing this. And whenever we intersect with something and we do have some piece left to map, we just push it back in the array in the vector of ranges. This is not very optimal because we are going to, for each range that we push here, we are going to loop a bit more than necessary in this range map, because we are in a certain range map now, and we know that these bits that we are pushing into the ranges to map don't overlap with any of the range maps before this. So it's looping a bit more than what we need. I think that we can probably express this in a different way that doesn't require more looping, like maybe a recursive function or something like that. But like saying, okay, this is this in this case this is the most complicated. We have 2 bits left, but let's think about this one. We have this bit left. We could say, okay, recursively map this thing, this interval with all the remaining of the range maps or something like that, and that would take care of things and be optimal in the sense of being like reducing the amount of iterations, but it will be more complicated, so I want to keep things simple. Yeah, gotta get going. Let's actually commit this, even with this beautiful to-do, because yeah, the idea now is to have the difference of the range and the intersection and just push the difference to be processed, and don't have to do all of this special casing. That would be great. So let's commit. Simplify day 5 code by modeling range intersection. Yeah, okay, it's not the best commit message, but let's push what we have. And that's it for today. Well, for today's video, I will probably come to this back later if I have some time to do so. But if not, well, I will come back at it tomorrow. Anyway, if you have been, thanks for watching and see you later. Bye bye. And we are back. So hello there. I want to jump back at what we were doing with the refactoring of day 5 into more reasonable mathematical interval math code. So yeah, where were we? Basically, I'm probably going to paste this video into the previous take to just make a single video of all of these refactors, if it's not too long. But yeah, the last thing that we did was to model this intersection method on range, which was really nice to generalize this case of, okay, put into the mapped ranges the mapped intersection part of our range. And then we have this mess that is the next thing that I would like to simplify now. So we are doing this on our to-do, simplify code by modeling interval, intersection, and difference. So I think we should be able to model range or interval difference. Let's sketch this out on the range type implementation or whatever. Section start, section end, rates. I was checking how intersection is done because I think that the difference might be somewhat similar, but not quite. Because, let's say, difference between two, well, it's not this. Let's do it. So let's think about the difference. Again, let's write some cases. If we have the range A be something like this, and then range B, like we are going to do the difference of A minus B, basically. Now, if B is something like this, it's like just basically, I think, well, let's count. These are the cases that we have right now. But we are working with this very manually. Instead of representing the difference as an interval, we are just checking all of the cases. And well, what is this case? This was the case. Range is entirely within the, yeah. So in this case, range is entirely within this other range. We want to make the difference between the range and the intersection to know what's the rest of the range that we still have to map. That's what we care about. We don't care. We no longer care about. We should not care about the range map. This is already taken care when we did the intersection. So in the case that our range is entirely within the range map source, which is another range, then the difference, the intersection would be the same as our range. And so the difference of range minus intersection is going to should be empty. And that is what this case should do. It should do nothing. All the other cases do something of pushing things into the ranges to be processed. Like these are extra ranges the difference ranges that we still need to process. And we have basically 3 cases of those. This, for instance, is when the range starts before our range map. So the difference is before that range, and we are pushing that. Like it starts at the same start and then has this length, whatever. This is the other way around. It's when it ends after the range map source ends, and so we push the last bit to be processed. And this is the most difficult case that we are checking first, because it is the case where those 2 conditions are true. It starts before and ends after the range map source. So basically the range map source makes a hole in our range, and we have to map 2 other bits of range, and that's what we are pushing here. So I want to generalize that. And basically this means that we have either 0, 1 in these 2 cases, or 2 ranges that can be the difference. And I could make this thing return something like a vector of either 0, 1, or 2, or we can make it return like an enum that lists all of those cases. But I think we can also, since we can represent empty ranges, we can just return a tuple of 2 ranges. And this will both be non-empty in this difficult case, but in the other cases it's like, okay, one of them it's going to be empty and the other one is going to be full or whatever, or both of them could be empty. I think that this makes sense. Like basically this would be like the left bit of our difference and this would be the right bit of our difference. So something like that. And they can both be empty or non-empty. So how, with that in mind, like how do we think about these two separately? Well, the left, let's see, like the left bit of difference here, when we do a minus b, like the result is gonna be, whoops, what? It should be a range like this. Maybe it doesn't include something like this. Let's put it on the same line as here. So it starts, basically the start of this, of the left bit, let me think. In this case, it's the minimum of the two starts. But if this thing starts before, then that is, no, we care about A. A is our like source, and we are subtracting B. Like this operation compared to intersection, like intersection is something a symmetrical operation, like commutative, I think it is in math. Like you can turn around self and other and the results should be the same. But this is not the case. This is a difference. So A minus B is not the same as B minus A, of course. And okay, so then what should we do? Let's say let left difference, we're gonna have a start, let's just say range new, and where is this range gonna start? Well, maybe I can do this with an if. I don't know if I can do it with like min and max, because no, okay, if our A, or self, I guess, starts before B, then that's the start of the left difference. Otherwise, like if B starts before, there won't be like the left difference should be empty, I think. So that's what we, and if it's gonna be empty, then it doesn't matter which one of the two is. So we can always say actually self start, and what changes is the length, because we are now modeling ranges as start plus length. Okay, so what is the length going to be? Well, now I think we need an if condition here. So if self start is before other starts, then then just self start, right? No, sorry, we are computing the length. So what is it going to be? Well, it's going to be this minus this, right? So imagine if this is, I don't know, at 5 and this is at 3. Yeah, the difference is 2, and this, yeah, it should be, the length should be 2. So other starts minus self start. Otherwise, it's gonna be 0. And I think that this actually could probably be expressed with saturating sub. Because we are doing other start minus self start. So what if, like, if self start is 1 less than this, this is going to be 1, and that's fine. If they are the same, then the length should be 0, and if self-start is larger, well, subtracting, if we didn't check that, subtracting would be an underflow. But I think that there is a other start, not wrapping, but saturating. Yeah, saturating. Sub. Yeah, saturating sub, I think is what. Self start. Is this what I want? So saturating sub. The minimum, the numeric bound instead of overflowing. Yes. I think that is what I want. Why don't I see the basic? Oh, okay. I'm not seeing the here. Basic usage is like, come on. Let's actually Google this. Whoops. Rust saturating sub? Yeah, that's what I want. We can clean this up. Nightly only. Really? Am I at nightly? I think I thought I was using Rust stable, but I maybe should just check this and assume that it works. Well, let's assume that this works, because I don't know, it's what makes sense for me. And then we're gonna have a write difference, which is gonna be another range. And okay, in a case like this, there won't be a write difference. So we are thinking about a case like this, where the write difference is gonna be this. So something like, something like this. And in this case, the start is going to be the end of the other range, I think. So other.end, and the length, what's it going to be? So then we are going to sanity check this, but I want to think it on the abstract. The length should be this minus this, right? So the end of ours minus the end of this. Imagine that this is at 3 and this is at 5. If it's gonna, well, if you are subtracting b, and no, actually this should be end plus 1. Because this end is inclusive. Yes. Right. Yeah. So, and the difference, it has to be what's on us. So you should start like after this end. Maybe to make it clear, it should start there. And so it's again this minus this. Imagine this is, 2 and 5. This should be start at 3, have 4 and 5, so it should be length of 3. So yeah, I think it is end minus this end. So self end minus other end. Okay. And let's return this left diff and right diff. Oh no, and this is probably also something that, of course, we have to do a saturating sub, because what happens if the other end is bigger? So if it is the case, if they are equal, then the length of the right difference will be 0. So it's this case. there is no right difference, and if what you're subtracting ends afterwards, then the right, again, well, doing this minus this would underflow, so we need to do a saturating sub. Saturating sub. Sure. And okay, let's think about what happens when things, for example, don't overlap. What happens when what we are subtracting is completely to the left of what we have? Then the difference should be, well, there should be no left difference, but there should be right difference, that is just the whole thing. So let's think about that. The left difference will start at our start, yes, but then it's going to be other end, so this minus self end, so this, so that's going to be 0, right? Because this is less than this, and we saturate, that's going to be 0, so no left difference. And right difference is going to be other end is not, this is not correct. So it's either other end plus 1 or our start. So if our start is after the end of this, so let's say self start or the maximum of that, right? I think so. The maximum between self start and other end plus 1. And the length, and I think, yeah, I have to do the same. And I do wonder if this is correct, but okay. Now the length is also not correct, right? Because we are doing self end and saturating sub of other end, but it shouldn't be other end. It should be yeah, if this ends before us, it should be that, or again, maximum with our self start. So if it starts, for example, at, I don't know, 3, we start at 3 and end at 5. So the range should be 3, 4, 5, range 3. So we are subtracting that, it's difficult to think. Should be self start minus 1? Is that correct? That doesn't seem right. Like, what is, when we have this end expression, but what is the length given the start and end? If this is, so if end is start plus length minus 1, then length is end minus start plus 1. Yes. So saturating of this might be a bit too much for length. So it's gonna be this. I'm not sure if I'm expressing this correctly, or if I will have to take care of all the different cases, like similarly to how we did it here, to make the difference. In that case, maybe it doesn't make sense to do this refactor. But let's think. If there is some overlap, then this does make sense. So it's going to be this this plus 1, the end plus 1. Sorry, the other end minus self end minus this end to have the length, right? That length will be shorter than the actual length of the of the interval. So we want to take the minimum of the two, right? Because then if we go too much to the left, then this minus this will be larger than the length of the interval. So we have to take the mean between the two. So this is one possible, and then we take the mean with self-length. Actually, we do have length. I don't know why I was thinking about how to compute it. Right, this is the right diff, and we already thought about the left diff that is okay in this case. Yes, okay, so that's one case. I think we cover the left and getting into this also right. Well, let's think about this for a second. So in this case, the difference should be something like this. This is fine, I think, and this is going to be the minimum between the two, so I think it's fine. Now, is the left difference in this case still is other start? Yeah, minus, yeah, okay, so the left is still okay. Let's leave the middle case for last. Now let's think what happens when this is to the right. Then the left difference should be, again, starts where we start. Yeah, and the length is other starts minus, yeah, no, you also have to take the mean with our length here, because this, otherwise, other start, this minus this, would give a longer length. So this should also take the mean with self length. Okay, and now they are pretty symmetrical, these two, so it gives me a bit more confidence. Sorry, in this case I wasn't drawing the correct thing. In this case the difference should be this, and then if this overlaps a bit to the right, let's check that this is still correct. So again, the start is our start, but the length is other starts minus self start, yes, and that's going to be the minimum between that and length, so this seems fine. And in this case, the right difference should always have length 0, so that is self start or other end. So in this case, the maximum is going to be other end plus 1, so it's going to start here, the right difference, so it should be empty. But then it's going to do the end of self, this minus the other end, so that's going to be 0, and then we take mean, so yeah, it is 0, the right difference when this thing is here. So this seems fine. And let's now think about the last case and the most complicated one. So we have an interval like this, and the difference should be, well, something like this. Let's make it a bit larger to think about, and then we have a right and a left. So does our code still work for this case? So the left difference starts at our start, that's fine, and the length is other start minus self start, yes. and minimum with self-length. So yes, that seems to be taken care of. And if that's correct, then I bet the right part will also be correct. So it will start at our start or end other end plus 1. So in that case, that is the maximum. So other end start plus 1 is the start of the right difference, and then the length is going to be self end minus other end, that or the minimum of our length, but that is the first one is the case for this. So yeah, I think that this covers all the cases, I think. Right, let's try it out and see what happens. So we're gonna have a difference. We're actually going to have a left diff and a right diff. Sure. And we are simply going to say what we are doing here, basically, but do it more generically. So if the left difference is not empty, then we're going to push that into the ranges to be processed further. So ranges push left diff. And if the right diff is not empty, then we are going to push that. And that's it. That should take care of all the different cases. If both of them are empty, none of them gets pushed, and so on. So what happens if I remove all of this code? I'm a bit hesitant now. So cargo run. Let's run it with the input. Come on. I think that is the correct answer actually, but I should run check all, and it is. Great, awesome. No more to do this. That is so nice. So this is so much less code than what we had. So let's look at the difference actually, and the diff. We had all of these gunk and complexity replaced by this nice method, like a little method that returns you two ranges, possibly empty, but that is it. That is great. Map the intersection, yes, and say put the rest of the unmapped range back into ranges to be mapped afterwards. The rest of the say put what didn't get mapped the rest of the unmapped range back into ranges to be mapped afterwards. Kind of not the best wording, but that's fine. That's awesome. This comment is not necessary. These two little fellas can be moved to the top because they are like very basic things. The intersection of two ranges might be empty in case they don't overlap. Since between two ranges, when doing range minus range I want to explain a little bit and maybe leave this diagram here. So this would be A, this would be B, and this would be actually A minus B. When subtracting range B from range A, the result can be up to 2 ranges, like this. If B is to the left, okay, like this, this method returns those two left and right. Differences. I want to remember how is the name of the result of a difference called, like rest? No, not rest. So, right. Resulting ranges. When the B range is to the left of range A, there's no the resulting, well, which might be empty in the cases, where the B range is to the left, or which might be empty, range is not within the A range. Something like that. Great. But this is really cool. Okay. Now we know that all of this. I think that was pretty nice refactor. We also have this. So yeah, we may calculate the difference and then push those things to be further processed. And then we say, okay, they did intersect. Actually, this intersect, we can actually say something like, why not use the present? Intersects. Okay, like it's not a thing of the past, it's just a thing that is. So we can maybe assign this when we are doing this, right? We can say it intersects if the intersection is not empty. And no, I'm not sure if I want to move that. I could move it here. So just say, okay, the ranges overlap. Instead of this, we can just say there is an intersection. Map the intersection. For the rest, yes, and then we break. Yes, and if we break here, and what happens if I'm wondering a silly thing. Can we say like break through here? Because in Rust, loops are expressions, so we might say, okay, it intersects if this loop says so. And what is the type of this? Breakthrough. Can only break with a value inside a loop. Okay, or breakable loop. Okay, we cannot do that in a for loop. That's all right. We can use a mutable boolean for this, no problem. So afterwards, if it didn't intersect with anything, we just push that range into the mapped ranges as it is. That's great. This should still work. Yes, it does. So that's a very nice change. We have done this simplification of code by modeling interval and interval intersection and difference. So let's commit this. Let's actually take a quick look to this. Yeah, sure. This gets, this is really nice. Look at this simplification. And yeah, it's the kind of simplification that is really nice inside of a triple nested loop. It's like much less to look at. And it also has a good name, like difference is a nice mathematical precise concept to extract into a little method. So that's great. So model range difference, or let's say simplify day 5 solution by modeling range difference. This gets rid of the 4 special cases for if special cases on the main loops, and instead handles the difference between between ranges in a generic way, something like that. Great. So that's almost everything that we wanted to do, except this. Try using, like, modeling the ranges instead of using range start and length. Let's actually, because now that we have, look at this, this is interesting. The length, if you mark all the occurrences, is not being used. Like, well, it's being used here, for instance, to map the seed numbers, but then it's not, and here to map the ranges. But we could use, like, if this were modeled as start and end, it will be used here at the end. And well, we are using the length here to compute the end or to say if it's empty or not, but we are crucially almost not using the length also in the intersection. It's not being used, and in the difference it's not being used either. Well, sorry, it's being used only once, and I think that would be simple to get rid of. So I'm quite tempted to at least try and see if we model the ranges like this by start and end, if it makes more, like if it simplifies things or not. So let's list the possibilities. We could have start and length for a range. We could also have start and end, but let's say they are like inclusive. Start plus length, let's call it inclusive. Or we could have start and end open-ended. Okay, so this is what we have now. The pros of this is that it maps well to what we have on the description, to the puzzle description. That it does have some cons, like you have to special case things when to not go under 0. So this is probably, yeah, this can also probably be expressed as a subtracting, how do you call it, like saturating sub, but okay. So many edge cases, and also something that I don't particularly like is like if you're using well, here we're using two 64-bit numbers. If the start is near the end, or if the length is U64 max, we cannot really, like, adding start plus length is going to be an overflow in 64 bits. So that's kind of a foot gun that I don't like. But it doesn't really count in this case, I guess. But in the case of the start and end being inclusive, I think it's kind of easy to think about. But the main problem, and this is a huge problem, cannot represent empty ranges. Because think about it, like if it's a range starting at 5, for instance, and only range of length 1, it will say 5 and 5. But that is still a non-empty range. It has one element. So how would you represent an empty range? You can't, unless you do end, 5, start 5 and end 4, so before or something like that. But that kind of sucks, and you cannot. In that case, you couldn't start a range at 0 because you cannot do -1 if you have signed the integer. So, not great. Oh, it's pretty late. I think I should get going. Again, I have something else to do. But yeah, all of this is to say I am tempted mostly to go with open-ended start and end. Although it is a bit weird to be like asymmetrical for the range. I think it doesn't have well, it can represent empty ranges just fine when these two numbers are the same. So start at 5 and end at 5, it means that the length is 0. And you can even have the end be less and still consider that less than the start, and still consider that an empty range. And yeah, I hope that this thing doesn't have as many edge cases as having the length. So also another reason why I would like to try to change this is that, if I'm not mistaken, when we introduce this end method, yes, we are using this for the intersection, and we are using it quite a bit for the difference. So it's like we are thinking about things in terms of the end. So at least in my head, it makes sense to have that. So let's try to model that. Instead of taking the length, let's take the end. And here we're going to construct it like this. And this is going to be a start end. But now we should check all the uses of this new, because what we are passing here is mostly wrong. We're passing lengths here. So intersection length, no, that's not what we want. We want to, well, in this case, this is actually probably the most difficult part. We want to also map the intersection end. So it should be intersection end minus range map source. What? Do we want the end here? How do we map any number? No. To map a number, it's just we still use the start plus the range map destination. It's like we are just mapping a single number. So the thing that we have to subtract is the same. It's the same difference. Yes. Okay. Then where else are we calling range new? Here in the intersection. So we have the intersection end, which is the minimum of the two ends. Okay. And can't we just say intersection end here and not care about whether one if it starts before the end or not? Because that would be nice if we don't have to care about that. It simplifies this code quite a bit. And the length, we could say if is empty, we could say that it is empty if the end is less than or equal to self-start, right? Okay, and where else are we using this? So I want to fix all the range new calls. Here 2 times in the difference, and when parsing. Let's fix the parsing first. Should be simple enough. We said that length is the end is going to be src starts plus length, right? So imagine if length is 1 and we're starting at 5, we say that the end is at 6, and that is correct. The 5 is part of the range, but 6 is not. So yeah, this was a pretty easy change. And here on the difference, which is the trickiest part and most important, I don't want to think about this again, but okay, let's go. Let's think about the general case, if we can make sense of it. The left difference. Now, instead of saying the length, so we don't have to calculate the length, we have to calculate the end of the left difference. So the end of this should be the start of B. So other start, yes, and it's the same number in this case because the end is non-inclusive. So it's either this, or if this is to the left, it's going to be self start. So I think it's going to be the maximum of those. No, sorry, we have to compute the end. Yes, okay, so if this is the left part, and if this is to the left, we don't care about. Well, this has to be empty, but other start is fine for, like, think about this. Other start is fine for this case. Then if this gets moved to the right and is over here to the right, it's kind of drawing for a bit, then the left difference should end where we end. So it's the minimum of other start and self end. So let's say self end min other start. And I think that is that it. I think it works for those two cases that we said. And what happens if it is like this, or more to the left, where the left difference should be empty? If it's the minimum of self end and other start, well, the minimum will be this. But if we are starting at here, this will be less than this, and so we are going to say that the range is empty. So I think that's fine, and that is great simplification over what we were doing. Awesome, it makes it even a one-liner. And is this the same case for the right difference, I wonder? So now this thing starts at start or other end, but that now the end method, oh, this is tricky. The end method that we had doesn't mean the same that it means now, because it used to be inclusive. So now we don't have to do +1 here. So look at this, it starts to get very, very reflective of this, or symmetrical to this. So, and where does this end? I think it will just be self-end. Like, can we say this? If we can say this, that would be amazing. So let's think about it. We're thinking about this piece now. So if self-start or maximum other end. So since the end is not inclusive, that is the correct value for the right difference. And it works at least in this case. If this goes over here, then the maximum of these two is going to be other end, of course. But since, and that will be the start, but it will end here, so it's going to be an empty range. That works. And if we go over here, let's say here, then the right diff start is going to be the other end, which is fine, and end where we end. Yes, so this is this is great. It's much better than before. Let's think if the intersection is fine with our non-inclusive end. I wouldn't be surprised if it is. So can we, maybe I should draw some diagram like this. Yeah, let's draw something. So it's nice to ranges A and B. Yeah, let's say I don't know if I want to document this all the way. I just want to make a drawing of the cases that we have. So let's say A and B, and I don't know if B is like this, and the intersection I don't know what's the symbol for intersection B, what's it going to be? Well, in this case, it's going to be this up to, no, not that. It starts here, goes all the way up to here. So the start is the maximum between self-start and other start. Yeah, that seems reasonable. For this case, it works. And the end is the minimum between self-end and the other ends. So yes, I think it is, you know what? I think it is correct. And it's so short that we can even inline these variables. Look at that. It's a one-liner now. Awesome. Let's trust that this works. Maybe it doesn't, but let's trust. And now we have almost everything. We have to interpret these seed values. Oh, here I wasn't using the range constructor. Let's use it. Range new. I'm gonna have a start, and the end is gonna be start plus length. Okay, that was quite a bit of a refactor, but will this work? Cross fingers. I'm actually not crossing fingers. Yes. I'm not that superstitious, but yes! That was a great refactor, and it worked right away. Awesome. So yeah, I was doubting whether representing ranges with start and end would be better than having a length, but it was definitely better. Like the difference got much shorter. The intersection got to a one-liner, and the only thing that got like more complicated is when we are parsing that we just have to do start plus length. So it's also something quite trivial to do. So this is simply great. We reduced quite a bit of lines, but also like everything in general got. Look at this. Look at the intersection. That's awesome. One line versus I don't know how many. It was definitely a good investment. So this is done. Let's commit this thing. Wait, before committing, I want to add a little bit of. We can get rid here of debug. We can say. Can I put this here? Yeah. These are open-ended ranges. So range new, I don't know, 3, 5, or let's say 3, 6 covers 3, 4, and 5. Great. Just a little comment there to know that these things are not inclusive because, well, maybe inclusive ranges sound more intuitive, but I bet you that they would have been more tricky in some cases. Like we would have to be adding ones. Like it's impressive how the difference got like perfect because like it matches, the start of things matches with the end of others. It's like, yeah, this is like the perfect representation for intervals. So let's represent ranges with open-ended start and as open-ended start end instead of start plus length. Yes, awesome. And there's probably more things that I would like to do, but I think I'm running out of time. One quickie that I want to try is to extract a little bit, like this thing got a bit uglier when we started using ranges. Like, yeah, I think let's. I'm thinking a bit over myself, but I want to have a function, a generic function that just takes the ranges and does the solution, does all of this, and call that for part 1 and part 2. So let's have this function, say min location for seed ranges, something like that, or just simply get min location or min location. That's probably also, yeah, no, for seed ranges. Let's be very explicit. And here we're going to take the seed ranges directly, and actually I think, well, let's say seed ranges, we're gonna see what we take, but this used to be part 2, so let's yank this. Yeah, let's yank this from here. We are going to still need a mutable ranges there, but here for part 2, oops, I'm gonna say min location for seed ranges. And what are going to be the ranges? Well, this thing, starting from the seeds and just making tuples and then doing this. And you know what? Maybe we can avoid collecting and we can just pass this. And you know what? Not even cloned. So start is this, but we can just dereference this. We were cloning before because tuples, you know, it simplified code before, but now it doesn't any longer. So this doesn't need to be mutable. We're going to move it into this function, and this, I think, will take just a generic impl iterator of ranges. Okay. Is this happy about this? No, not seeds, ranges. You don't like this, you can have this. Great. And now we still need to do let's mute ranges as we used to have, which is going to be a vector of something, and just do seed ranges collect. Like we are going to, whoops, just collect. We're going to consume here, and this compiles, and we can call this thing, oops, part 2 ranges, p2 ranges part 2. And then for part 1 we are going to do basically the same thing. Yeah, whoops, just call this thing, but we are going to do this instead. Something like this. So the iterator that we are going to pass here, and let's say let's ranges part 1, It's going to be iterating over the seeds, not flat map, it's just a simple map. And we are going to construct a range new starting at the seed number and the, no, not the length, and ending at seed plus 1. And this is ranges part, no, not part 2, part 1. Great. Bye-bye. And that's it, I think. We have some ranges for part 1, some ranges, like different ranges for part 2, but then the thing is computed the same way. Yeah. Answer 1 is this, answer 2 is that. That looks pretty good to me. Can we say something like tuple here and just use tuple 0, and tuple 1? No, you cannot infer that. So let's keep it as this, starting length. Fine. Yeah. I think this is more explicit, at least than what we were doing before. I prefer to have like a generic function that does the thing, but we haven't tested this. Does this still work? Yes, it does. Okay. I think that's it for the refactors that I wanted to do today. Let's commit this. Extract general, say day 5. Extract generic solution function and use it for part 1 and 2. Okay, great. And I will count that as simplifying the main logic of things. So we learned a lot of things about how to do interval math when programming. Like at the beginning of this puzzle, I felt super bad, but now I feel like I have learned some things. So let's take note of these learnings. I will actually then add them here I usually take notes of each day and if I learn something, but I don't want to forget. So modeling math operations like intersection and difference pays off by a lot, and using open-ended starts and ranges is better than start plus length. Yeah, I think those are the two main learnings of today and yesterday. So I will try to remember this for if we have some other puzzles to do some interval logic. Because in the end, with these things applied, I think that the code ended up looking, I don't know, just way nicer than the mess that we had before. And it only took, like, these functions also ended up being quite simple, but very, very powerful, like intersection and difference, super powerful for what we needed, and they weren't so complicated. I feel like if I would have tried doing this for like the previous video, what I did yesterday night, it wouldn't have taken me so long to come up with a working solution. But of course, hindsight is 2020. Now I know that modeling things, at least in this way, really pays off. So I will try to keep that in mind for the future. But anyway, that's it for this video. It's already a bit late for me. But if you haven't, thanks for watching and see you later. I guess today night or tomorrow for the next puzzle. Bye bye.